In this video, we are trying to look how we can utilize the Protobuf Kafka Stream solution from Bitquery to build useful applications like the one for monitoring withdrawals and deposits to the Binance Exchange wallet addresses. For the sake of this tutorial, we have a list of Binance Exchange wallets for the BSC network, and we are going to utilize the Protobuf Kafka stream solution by Bitquery to get any deposit or withdrawal from or to these addresses. So without any further delay, let's jump into the program. So firstly, we have a bunch of imports. We are importing OS, UUID, the Confluent Kafka, consumer Kafka error and Kafka exception. We are importing decode error from google.protobuf.message. From EVM, we are importing token underscore block underscore message underscore pb2. This is a package created by Bitquery for the ease of development. Otherwise, you would need to get the protobuf files and manually get them into your project directory. Also, we have a bunch of imports like BinASCII, Base58, JSON. Then from the other files that we have created, we are importing convert bytes from helpers dot convert underscore bytes, which is this file. So this is basically a function where we are checking that if the encoding is base 58, then we would decode that message and return that message. Else we'll return the value dot hex. So basically it gets a encoded message and returns a readable string. Then from constants.py I'm importing star. This is basically the credentials for the stream. Now after the imports, the first line you could see is I'm using uuid.uuid4.hex. Basically it creates a random hexadecimal value. Now to access the Kafka stream, we need to create a consumer, and for creating a consumer we have to have a configuration. So firstly we are defining our server endpoints, which are these three. Then we are describing a group ID that is a join of username, group, and group underscore ID underscore suffix. So we have created this random variable earlier because for the same set of credentials, more than one consumer could access the stream. Then we are defining other things like the session timeout, the security protocol, the SSL endpoint identification algorithm, SASL mechanisms, the username as the username, the password as the password from the constants file, the auto offset reset as latest to get the latest messages. Then for this configuration, we have initialized the consumer. Then we have to select a topic. So the topic has to be according to your use case. Our use case was to get the withdrawals and deposits from and to these particular wallets of any token. So the most natural choice for this tutorial was the bsc.tokens.proto. Then we subscribe to this topic using the consumer.subscribe topic. This is the list of wallets, which is not actually a list because a list would look like this. But you can see instead of square brackets, we have curly one. The reason for this is that the set is so the curly brackets actually implies that a set is created and we are using a set instead of a list, as the set has a faster lookup. So the purpose here is to minimize the overall latency. Now let's have a look at the process underscore message function. What it does is it receives a parameter as message, then it tries to get a buffer from the message as message dot value. Then we'll have a passed underscore message as the token underscore block underscore message underscore pv2 dot token block message. So basically what it does is it loads the schema of the protobuf message topic that we subscribe to. Then in this line we are comparing the message we received from the stream to the schema and getting a kind of object. Then we are looking to get the transfers from this passed underscore message object. So the transfer are passed underscore message dot transfers. Now we'll iterate these transfers, that is for transfer and transfers. We are defining the sender as 0x plus convert bytes transfer dot sender and receiver as 0x plus convert bytes transfer dot receiver. We have added this 0x because the convert bytes of these two values doesn't have a 0x in front of it, but we know that any EVM chain address starts with an 0x, so we have added it on our own. Then this is the statement from which we could get the amount of the transfer, that is int from underscore bytes transfer dot amount, the byte order as big, and the value isn't doesn't really returns the decimal, but we know that for any EVM chain, but we know for BSC it's 18 decimals, so we divide by 10 to power 18. Then we define currency as transfer dot currency and the symbol as the currency dot symbol. So now we put our conditions that if sender in wallets, then we'll print this statement that is this receiver has withdrawn this amount of this currency from the sender exchange wallet, and if receiver in wallets, then it's vice versa. Then we'll print sender has deposited this much amount of this much current of this currency to the receiver exchange wallet. Now these are the lines for error handling. If it's a decode error, then this message is printing. If it's an exception, then this message is printed. Now let's jump to the main loop. We'll try while true to get message as the consumer.poll with timeout equal to 1. If message is none, we'll just continue. If message throws an error and the error code is the following, then we'll continue. Else we'll raise an exception. And finally, if none of this is happening, we are receiving a message and it's not throwing an error, then we'll just pass that message to the process underscore message function. And this is the line for handling keyboard interrupt. And finally, we'll close the consumer. Now I'll show how to run that. I'm using the command line over here. Okay. And you can see we have kind of built our mini project to monitor the Binance exchange wallet addresses for any kind of deposit or withdrawal. You can see a lot of USDT deposits. If I could have run this for larger time, I could have also shown withdrawals. So thanks for watching, like, share and subscribe. And if you have any doubts regarding this whole project, or if you want to know about the Kafka solution from Bitquery in general, To make a more scalable version of this project or any other project of your choice, then reach out to team via Telegram. Link of the group is in description. I'll be sharing the link to the documentation of this tutorial and the complete code base in the description of the video as well.